In this video, we are going to cover some useful facts about the probability limits. So let's define two random variables that depend on the sample size, Tn and Un. And let's say that the probability limit of Tn is alpha, and the probability limit of Un is beta. So the probability limit of Tn plus Un will actually be alpha plus beta. So that's already the case with, for instance, the expectation. The expectation of a random variable plus another random variable is the sum of the expectation. The probability limit has the same property, but it has other properties that the expectation doesn't have. The plim of a product of random variables, Tn times Un, is actually the product of the probability limits. That's not the case for the expectation. The plim of a fraction with having random variable both at the numerator and the denominator is although the ratio of the plims, alpha over beta. And that's only, of course, if beta doesn't converge in probability to 0. Otherwise, we'll have 0 at the bottom. Oh, sorry, not beta. Of course, if Un doesn't converge in probability to 0. We have actually something even stronger. If f is a continuous function, the plim of a function of a random variable will be actually the function of the probability limit of this random variable. So we say that Tn, the probability limit, was alpha. That is called the continuous mapping theorem. So this theorem is very useful because when we have the convergence of a variable, a random variable, to some value, we can apply any function to it, and if the sample size becomes large enough, we can just get the function of the value towards which it converges.